सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics, and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Radioactive Community Radio, Bengaluru.
एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज, की आवाज।
Latest information on STEM popularization.
Cutting-edge quantum technology backed green hydrogen production unveiled to power a green future. A new, high-throughput, quantum-backed green hydrogen production technology could boost the green hydrogen production in bulk. The technology developed by the Green Capillary team from Banaras Hindu University was inaugurated at the university in Varanasi by Dr. Anita Gupta, head of the Climate Change and Clean Energy Division, DST, and Dr. Ranjit Krishnapai, Scientist and Director of Climate Change and Clean Energy Division, DST, and Professor R.R. Sonde, Chairman of the Expert Committee, IIT Delhi, in the presence of eminent domain experts drawn from all over the country. The technology developed by the team, comprising of Dr. Somnath Garai and Professor S. Sri Krishna, showcased the uses of green hydrogen as eco-friendly energy alternatives. They introduced next-generation quantum-powered photocatalyst with the charge transfer system coupled with the high proton availability and mobility, and delivered quantum catalytic application for energy generation. The patent for this technology, supported under the project titled Boosting the H2 Economy by Harnessing the Merits of Quantum Encompensation Chemistry, Augmented Kinetics for Water Splitting Reaction under Confinement, under Hydrogen and Fuel Cell Program, Clean Energy Research Initiative is pending. The state-of-art photochemical reactor design features built-in illumination assembly and external concave reflexive panels to maximize the capture of solar energy. The team has engineered a continuous electron-coupled proton supply system. The team has engineered a continuous electron-coupled proton supply system propelled with an electron injector mechanism utilizing industrial metal waste. And after rigorous optimizations, the peak rate of green hydrogen production at lab scale was achieved to be about 1 liter per minute and 10 grams of quantum photocatalyst. Due to high purity of the hydrogen gas produced, the fuel can be used without additional purification, thus enhancing the cost effectiveness of the technology. This transformative innovation would offer wide-ranging application possibilities across various sectors ranging from energy production to application in transportation and agriculture.
Now, our next segment is Analyst in STEM.
Today we are with Dr. K.R. Sreenivas, Professor, Jawaharlal Nehru Center for Advanced Scientific Research, Bengaluru.
My background is a mechanical engineer. My name is Sreenivas. Work in Jawaharlal Nehru Center in Engineering Mechanics Unit. And I basically work in thermal science and fluid mechanics area. That's my background. And the research activities, whatever I am doing, is related to application of these two broad theme into both fundamental and applied research.
Okay. Can you give any specific about your research topic?
See, essentially, I have a couple of broad areas, I would say. It's always trying to look into the application of thermal and fluid engineering for solving the problems. I work on atmospheric science, geophysical flows. Okay, that's one broad topic. Other one which I work on is thermal management, both for applications such as ventilation, air conditioning in a building, to agricultural applications wherein which you have polyhouse and protected agriculture. In those scenarios, how to manage the heat load is the application. And I also look into other two topics, which is turbulent drag reduction, fundamental aspect. It's a little away from taking to the application, is that by adding some of the polymers into this flow, you can reduce the pumping cost. Hence, how it functions, what is the basic science behind it, is one thing which we are looking in. And little before, I also looked into insect flight and flight dynamics, how insects and birds generate lift by flapping their wings, in contrast to fixed wing aircraft or rotary helicopter kind of a scenario. Okay. Now with micro air vehicles and many applications, they are called bio-inspired locomotion. The flapping flight comes under that. These are the areas in which you basically have many of the application what I am describing to you.
Okay.
Fluid mechanics and thermal systems. These are some of the areas which I work on.
Okay. How is your research beneficial to a common man or India as a whole, and what kind of contribution is it making to the field of science in India?
Okay. Some of the topics which I am looking are fundamental. For example, I said usefulness of a turbulent drag reduction, as I indicated, can reduce the pumping cost. But the work what I am doing is bit of fundamental in nature, in which I am trying to understand the mechanism of the drag reduction. Hence, it's a couple of steps away from the direct application. But I would also say that there are application-oriented topics on which I am working, which is directly relevant to the society. For example, atmospheric science, I said. We are working on how nighttime thermal structure and heat transfer occurs in the atmospheric boundary layer. We were first to explain one of the 80-year-old mystery of some temperature structure, vertical variation of the temperature in the atmosphere, by fundamental work of showing that the dust particles and which we generally call aerosols, it could be droplets or dust particles, can change the temperature profile, can change the cooling rate in the atmosphere, which has a direct application to the prediction of fog, when the fog occurs, when the fog disperses in the atmosphere. You know very well that the number of flights which are disrupted, and because of the direct application, Bangalore International Airport is funding a project with JNC team. We have observation centers right next to the runway. Okay, we do in the winter time do give a bulletins which will tell you what time that day probability fog occurs and when the fog is going to lift, what is the visibility. All this information we do share with the airport. Similarly, another project which I am working is the protected agriculture, thermal management in protected agriculture.
Okay.
What I mean by protected agriculture, protected from insects and the heavy rain and atmospheric vagaries, which broadly, it's a broad area, specifically polyhouse and the small growth chambers, which you can use for agriculture purpose of high value crops based on the it could be plant breeding or it could be medicinal plant, and all those agriculture application requires a very controlled environment.
Okay.
We are trying to change the thermal load on the system. We have an active collaboration with Agriculture University Bangalore and Indian Institute of Science Mechanical Engineering Department. With the colleagues over there, we are essentially designing various things. And you remember, some of these protected agricultural things are developed in for the countries other than India, not a tropical countries but higher latitude nations. When you import that or try to adapt that here, we do run into thermal load problems. We are looking into it. These are some examples wherein we can directly say that society is being impacted.
Okay. Could you brief about your past, present, and future area of research?
As I indicated in the earlier question, I do work on thermal and fluid mechanics problems.
Okay.
Earlier I was working, for example, insect flight related work, which presently I am not actively pursuing, which is a flapping thing, but now many UAVs and MAVs, that's micro air vehicles and unmanned vehicles, have been built based on either a small fixed wing configuration or by using rotary wing configuration. But still, there are some advantages with a flapper, which is almost like a natural. This one we were again first to identify one of the lift generation mechanism. But presently, I am not looking into that problem. As I said, the current projects which I am looking are one is atmospheric related problem, in which we are having a collaboration with Bangalore International Airport, and another is agriculture research related to the thermal management in the thing, and making efficient heat transfer, heat exchanger. For example, we developed a solar collector based on the input what we got from study of this aerosol or dust particle in the atmosphere, how they do the heat transfer. We designed one heat exchanger which has a higher efficiency. That has other applications also. We are looking into those aspects. These are the areas which I am working.
Thank you, sir. Do you have any idea about where India is right now ranked at in your field of research?
That's a bit, I don't know what you mean by rank over here. I would rather say that is our research being identified and is it new or novel enough? Okay, for example, what we are doing for atmospheric thing is really new, and the success rate of any of the fog predicting programs, okay, whether it's in India or abroad, is very bad. In the sense, unless otherwise you can always develop some predictability code which would have a statistical means of saying when the fog is going to occur. That's one way, one approach. But what we are trying to do is by going by actual physical reasons, physical parameters which are impacting the fog. This kind of success, we actually coupled with the observation and the simulation and using machine learning algorithms, we were able to last fog season, we are able to have a success rate of close to 76%. Okay. I believe this is unique, and I think I would say that it's one of the leading research group which is doing this kind of predictions. That much I can tell. Now, when I'm telling that, it's internationally in the forefront in this area. And coming to agriculture application, I clearly told this kind of designs for protected agriculture exist elsewhere in the world. Now, they are, for example, if you are having in Denmark, which is a place where many of the protected agriculture, they are leaders. Okay, they have a different problem. They are in the cold region. For them, conserving the solar heat in a structure is more important for the healthy growth of the plant. But when you come to India, conserving heat is not a concern for us. Actually, we don't want heat. We have temperatures in certain area shoots to 30, 40 degrees centigrade, 40 degrees centigrade, there are areas, arid conditions. Hence, for us, rejecting heat becomes a problem. Hence, now the question is, do you want to be doing the same thing what the international people are doing, or you want to do something different for an Indian condition, which they would not look in. Hence, we need to look and then solve the problem.
Yeah.
Hence, sometimes you need to be internationally competitive and doing the job what they are doing. Some other times you need to look at your local problem and try to address that one using various other means which they have not thought about. Okay, I would say that both are being done.
It would be helpful if you share some information about your contemporaries.
Again, I work in a couple of areas. For example, related to fog and atmospheric research, I think a couple of people at Indian Institute of Tropical Meteorology, and there is a group in IMD headed by, I think, IMD group, which are doing fog prediction in the Indira Gandhi International Airport. That's related to atmospheric related thing, and nighttime temperature profiles, and then transport. There was a person at IIT Delhi. He was looking into the stable boundary layer, and Maithili Sharan, Professor Maithili Sharan, he was looking into it. And flapping wing aircraft and application. There is one of my acquaintance and faculty at IIT Kanpur. There are certain group, Professor Debapam Das and Professor Arya at IIT Bombay. These are the people which comes to my mind. But each one are looking into different niche areas where this technology needs to be transferred. And regarding agriculture thing, I said this is a large consortium. Actually, it is part of the BEST cluster, basically Bangalore-based science cluster, where Government of India has given emphasis and impetus to look into protected agriculture, which involves Jawaharlal Nehru Center, couple of scientists, myself, looking into thermal side, and Ishwar Murthy looking into the insect control, and another ICAR institute, wherein which another colleague of us, Subharan, is looking into it. IAC, Babji, Professor Jayavant Terikiri, and many other people are looking into thermal side, and agricultural university scientists are also involved. Hence, it's a large consortium of people looking into this.
Okay. How are Indian industries associating with your research project?
I think my answer already had this one. This one, for example, Bangalore International Airport is collaborating with us. And some of the projects, for example, drag reduction was earlier. We had a program to design, to evaluate different polymers with HP, Hindustan Petroleum. HP Green campus is there in Bangalore, and they are funding it. And some of the other projects which we have, BARC had shown interest in one of the thing which involves some modification of solar heat collector. I said no to some other application, and some of the agriculture thing which we initially had an industrial collaboration, but during the COVID time, that particular industry, floriculture thing, went out of business. I think we will revisit it once they establish. It was a bad time in which we could be able to proceed further. But definitely there are industrial interests in that area also.
Here we are, signing off. Stay tuned with us to catch up on the latest science updates and learn about STEM experts.